This desk that I have out here in front right now, if I asked you to measure it, what type of units would you measure it in? Inches. Anybody do it in a different one? Could you do it in a different one? How else could you measure this? Inches, feet, centimeters. Maybe somebody goes crazy and goes millimeters. There's different ways to measure this desk, correct? If I asked you to measure this angle, there's only one type of unit you're giving me. You're going to give me a number with what type of unit? Degrees. That's all you know in all your life. As I only measure an angle in degrees until today. I'm going to give you a second unit to measure an angle. I know that's kind of like a mind-blowing thing that there's actually something else out there you can measure an angle in other than degrees. And it is called a radian. Okay, you can measure angles in what's called a radian instead of degrees. Just to give you a sense, please don't copy this down because I'm not going to use it. Just to give you a sense on how degrees and radians compare, 1 radian is about 57.3 degrees. All right, so 1 radian is about 57.3 degrees. All right, we are going to start measuring angles in radians. Okay, we are going to start measuring angles in radians and bounce back to degrees to radians. So all I want to do with you today is, if I have a degree measure, how do I turn it into radians? And if I have a radian, how do I turn it into degree? All right, so let's start with, if I have a degree measure, how do I turn it into a radian? All right, the way we're going to do it is we're going to multiply the degrees by a fraction here. Okay. So take my degree measure and we're going to multiply it by a fraction. Please go to the very back of your packet. I have provided everybody with a reference sheet. Now, you may already have one on you from another unit we've done this year. All right, everyone see that reference sheet that's staring you in the face? That is the same sheet that will be on your desk the day we take the Regents. Okay, you're allowed to have that sheet on the Regents, so I'm going to allow you to have that sheet for any test or quiz. I want you to look down the second column there, second column. And look where it says degrees, please. Look where it says degrees. John Carlino. All right. Yeah, I guess. That's fine. Yeah, that's fine. Yeah, I'll do it. No, I just usually do something else with my double period there, but it's fine. It's fine. I'll get it done. Okay, thank you. Yep, bye-bye. Okay, so multiply the degrees by, everyone take a look in your degree column there. Take a look in the degrees column. Multiply it by, everyone see that fraction that's there? What's it say? Pi over 180. So that is what I'm going to multiply all the degrees by. And you can use that. You don't need to memorize this. This is something you can just go to the reference sheet and use. Okay, so here we go. Let's do this for the first time. 30 degrees, put it into radians. So I take my 30 and I multiply it by pi over 180. And I'll do this with you too right now, because there's going to be a problem here that I'm not a big fan of. All right, so here we go. So I do 30 times, get my fraction template out, pi over 180. And that's what I end up getting. All right, everyone else getting that in their calculator? So it's about what? About half a radian? 30 degrees is about half a radian, not even a full one. But you guys have known me since September here. I definitely don't want that full decimal, and we don't want to write it out, do we? And I don't want you to round it either. So here's what we're going to do. Anytime we leave our answer with radians, we're going to leave it in terms of pi, because I do not want that thing written out. I don't. So we're going to leave it in terms of pi. So let's remember how we do this. So we're just going to slap the pi, put the pi in our answer, And now in your calculator, do 30 over 180 for me. 30 over 180 in your calculator. Put the pi in your answer, divide the rest. So 30 over 180, and I want it as a fraction, not a decimal. So 1/6. So 30 degrees is the same as 1 pi over 6 radians. Okay, 1 pi over 6 radians, which is the exact same thing as that long decimal we had. So anytime you leave your answer in radians, leave it in terms of pi. All right? Look good? All right, let's keep going. One doesn't make you great. 45 degrees. 45 degrees in radians. Multiply it, pi over 180. Again, leave the pi in your answer. And go ahead and reduce 45 over 180. And what's 45 over 180 reducing for you right now in the calculator? 9? No, not here. 4?
1 pi over 4.
Yep, 1 pi over 4. And you don't have to put the 1 if you want. That's fine. Pi over 4 radians. This is on the formula sheet. You just got to look for where degrees is. All right, keep going. 60 times 60 degrees in radian measure. And 17, we end up with what here?
Pi over 3 radians.
Pi over 3 radians. And then how about 90? I'm going to add a number 5 in too here. $90 degrees. 13.
Pi over 2 radians.
Okay. All right, hold on. Before we go to the next here, I want to add in a number 5 because this has always been 1 over something, right? I just want to make sure we can write it if the number on top's not 1. So can you guys do, let's see, 135 degrees for me into radians? $135 into radians. So what'd you get for your reduced answer? 10?
3 pi over 4 radians.
Okay, so you got 3/4. Now it's 3. Good, Josh. 3 pi over 4 radians. That's how I would write it. I just wanted to do something when there was different than a 1 there. All good. And again, I do want to let you know the why behind this. Why am I having you convert it? Because on Monday, you're going to get a formula where only radians works. So what happens if we got the angle in degrees? You're going to have to convert it over before using the formula. All right, so here we go. Let's go backwards now. Radians to degrees. Also on your formula sheet. Now instead, we'll multiply radians by look in the back, look where it says radians so you can know where to find it. Because I'm giving you this formula sheet, any quiz or test, this unit, and it's on the Regents. 180 over pi now. Yep, so I multiply the radians by 180 over pi. All right, let's do this. So if I have 7 pi over 6 radians, how many degrees is that? 7 pi over 6 times 180 over pi. Hey, let me just go back to your algebra days. Do you see what you have in the top and on the bottom? What's the same that's on the top and on the bottom? So those will cancel out. All right, those will cancel out. So really what you end up doing is 7 times 180 over 6. That's what you're going to end up doing. Numerator times numerator. And I think if you just put it in your calculator, you should be fine too. All right, with the pi's. If you just put it in the calculator without crossing them out, you're still fine. And what are you left with? 19?
210.
Got it, 210. So go ahead and try out 6 and 7. Hold your horses on 8, though. 8's a little different. All right, convert both these radians into degrees. All right, what do we end up with? 12 for number 6. How many degrees? No 12. All right. 11. 108 degrees. And then how about 7? 5 pi over 3 radians. 8.
300.
300 degrees, yep. Any issues before we get to the last one? Okay. 3 radians. Notice there's no pi. Don't put one with it. Radians can be expressed without pi. This is just 3 radians. That's it. 3 radians. So 3, what am I still going to multiply it by? 180 over pi. The only difference here is you guys that have been crossing off the pi's, did the pi's cancel here? No, there's no pi to cancel. So I'm just doing in my calculator 3 times 180 over pi. There will be times where the pi's don't cancel. They do not cancel all the time. And here's an example. Radians does not have to be left in terms of pi. We do it so we don't have to write that long decimal. And do this for me. Round to the nearest tenth on this one. Round to the nearest tenth. What are we looking at nearest tenth here? 7.
171.9.
There we go. Okay, questions? Definitely should be done with the homework by the end of class, but speaking of the homework, go to the homework for me. All right, the last question can get a little tricky. I just want you to steer you in the right direction. Not solve it for you, just steer you in the right direction. It deals with the clock. All right, and I'm looking for how many degrees and radians does the clock's hour hand move from 1 to 9? Draw yourself a clock at the bottom. Go ahead, draw yourself 12 to 12 clock. 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I just wanted to be clear what I'm asking for. And then draw 2 hands, one at 9, one at 1. And just so we're clear, I'm asking for the angle from 1 to 9 right now. So this angle right here, how many degrees? How many radians? Okay? That's what I'm looking for, that angle. How many degrees are in a circle again? Is this less or more than 360? Less, right? So your answer should be less than 360, not in the thousands, like I've gotten a couple times during the years. All right, I want this from here, and I gave you a hint. Hey, I gave you a hint that every time I go a minute is 6 degrees. All right, that's the hint I've given you. Every time you go a minute, it goes 6 degrees, the hand. So there's your hint. All right, on you. The rest of you's on you. Go ahead. What? Go ahead.